So remember the 4 steps in hypothesis testing. The first step is to state the researcher's and null hypothesis. The second step is to perform the appropriate statistical procedure. The third step is drawing your conclusions. And the fourth step is to write up your results. You can always get sample language to help you write up results in the cronk text. So the first step is to state the researcher's and null hypothesis. So we may state our researcher's hypothesis as having symptoms of Alzheimer's disease is related to estrogen replacement therapy. So we're going to hypothesize that there is a relationship between these two variables, that they are not independent of one another. Of course, the null hypothesis states that having symptoms of Alzheimer's disease is independent of ERT. So we're going to hypothesize that there is a relationship. The null hypothesis says that these two variables are independent of one another. Another way of saying that is that they are related. So then what we do is we go ahead and we compute the chi-square test of independence in SPSS. So in this data file, you can see we have 2 variables, whether or not the subject has had estrogen replacement therapy and whether or not they have symptoms of Alzheimer's disease. In the variable view tab, we can see how the data file was set up, where we have 0s equal no and 1 equals yes. Remember that for a chi-square test of independence, both variables must be dichotomous. So in order to run the cross tabulation and the chi-square test of independence, we can go to Analyze, choose Descriptive Statistics, and then choose Crosstabs. This will bring up the cross tabulation table. I'm going to put estrogen replacement therapy variable in the rows and symptoms of Alzheimer's disease in the columns. It really doesn't matter which variable you put where, it'll just change the look of the cross tabulation. I also need to ask SPSS to compute the chi-square test of independence. I can do that by choosing Statistics and selecting chi-square and click on Continue. Now I'll click on OK. It will produce the cross tabulation and the chi-square test of independence. In the cross tab, you can see there are 10 subjects who had no signs of symptoms and did not use estrogen replacement therapy. You can see there are 5 subjects that do have symptoms of Alzheimer's disease and participated in ERT. There are 9 people that have clinical signs of Alzheimer's and participated in estrogen replacement therapy, and there are 5 that have no signs of Alzheimer's and participated in estrogen replacement therapy. Here we can see the results of our chi-square test of independence, where the Pearson chi-square value is 2.778. We'll call that 2.78. Of course, there's 1 degree of freedom in a 2x2 table, and the exact probability that the effect is due to random variation is 0.096. We'll call that 0.10. Now that we've computed the chi-square test of independence with SPSS, we know that the chi-square value is equal to 2.78, and that the probability that the effect is due to random variation is 0.10. Remember, we round up. So what we could see is that 0.10 would be right about here. It's greater than 0.05 but less than 1 on this probability graph, and so that would let us know to fail to reject the null hypothesis. So if we fail to reject the null hypothesis, we would have to look right at it, and that would tell us that there is no relationship between Alzheimer's disease and ERT. That is, having symptoms of Alzheimer's disease is independent of estrogen replacement therapy. Any effect we were to see in the cross tabulation from our sample data is simply due to random variation. Remember, the null hypothesis always says that any effect or relationship you see in your sample data is simply due to random variation, that the relationship does not exist in the population. And then we would need to write up our results. We can get sample language in the cronk text to help us write up our results. We might write it up like this. A Pearson's chi-square, there we go, was used to determine if, remember always proofread your work, having symptoms of Alzheimer's disease is related to having estrogen replacement therapy. No significant relationship was found. The chi-square of 1 degree of freedom is equal to 2.28, and the probability that the effect is due to random variation is exactly 0.10. Then we always have this last sentence like we would explain it to our grandmother. Having symptoms of Alzheimer's disease seems to be independent of having estrogen replacement therapy. Well, there you go. We've computed the chi-square and found out that there's no relationship between having symptoms of Alzheimer's disease and having estrogen replacement therapy. As always, if you have any questions, make sure you stop by during my office hours. Have a great day.